What are harmonics in spectrograms? Have you ever listened to a bird singing and wondered how they create such beautiful sounds? One key element in understanding these vocalizations is harmonics. So, what exactly are harmonics in spectrograms? When birds vocalize, they produce a fundamental frequency, which is the main pitch of the sound. But that's not all. Along with this fundamental frequency, there are additional frequencies that appear at regular intervals above it. These are known as harmonics. Harmonics form a series of overtones that accompany the main sound. The fundamental frequency is usually the loudest and lowest frequency. In contrast, harmonics are multiples of this fundamental frequency. This combination creates a richer and more complex sound pattern that is essential for bird communication. When we look at a spectrogram, which visually represents sound over time and frequency, harmonics show up as parallel lines or bands stacked above the fundamental frequency. These lines indicate the presence of higher frequency components that make up the bird's vocal signal. The brightness or intensity of these lines reflects how loud each harmonic is at a given moment. For many bird species, harmonics play a vital role in their vocal communication. Birds often produce calls and songs rich in harmonics. This richness helps convey important information, such as species identity, individual recognition, or even emotional states. The pattern of harmonics can also influence how easily other birds or predators can locate the source of the sound. Some birds have calls with fewer harmonics, making it harder for predators to pinpoint their location. On the other hand, birds with many harmonics can have their calls travel differently through dense foliage. This variation can be crucial for survival and communication in their natural habitats. From the perspective of birds, harmonics add complexity to their songs and calls. These overtones make the sounds more distinctive and effective for communication. Researchers use the way harmonics appear and change on a spectrogram to study bird vocal behavior and ecology. This visual tool reveals details that may not be easily heard by the human ear. Analyzing harmonics in bird spectrograms helps scientists identify species and understand their communication strategies. It also aids in monitoring bird populations and studying how birds adapt their vocalizations to different habitats or social contexts. The harmonic structure can influence how sound travels and is perceived in various environments. In summary, harmonics in spectrograms are the series of higher frequencies related to a bird's main vocal pitch. They are visible as multiple lines above the fundamental frequency. These harmonics enrich bird sounds and influence how those sounds are used and received in nature. Understanding harmonics provides valuable information for studying bird vocalizations and behavior.